All right. In our last discussion in this series of videos on how to accomplish this kind of transformation, we're actually going to go to the Wittig reaction. And it's not just the Wittig. We could also talk about the Horner-Emmons-Wadsworth reaction. Or I guess most people call it the Horner-Wadsworth-Emmons, whichever one it is. We can use both of those or the Wittig. I'm going to talk about the Wittig. So this transformation that we've shown, going from a ketone and alkylating it at the alpha carbon, is difficult. We talked about why. People didn't have LDA in the earlier days of chemistry. So how is the Wittig going to solve this problem? Well, if you remember, the Wittig can be used, not exclusively, but can be used to make alpha beta unsaturated ketones. So if we have a carbonyl compound and we treat this with a halogenation source like Cl2, or I think we've talked about NCS, and some acid like acetic acid, we can halogenate at the alpha position. And so, we could use bromine and do a bromination, but we can make these alpha halo carbonyls. Okay, fantastic. And then, in terms of the Wittig reaction, we then took this alpha halo carbonyl and we did an SN2 reaction on it. And we made, or if we use this compound, we make a phosphonium salt like this. Now, what do we do with this? As it turns out, this phosphonium salt, not all phosphonium salts, but this one, because in addition to the phosphonium, we have an electron withdrawing group over here, we can actually deprotonate this with a non-super strong base, not with LDA. We can use something as simple as sodium hydroxide. And that will form deprotonate this alpha carbon. Let's show that. And we'll form this enolate. Now we've made our phosphonium ylide. Well, what do we do with ylides? We treat them with carbonyl compounds. Especially in this case, aldehydes. And what's going to happen if we do this, if you review your Wittig chemistry, we're going to lose our phosphorus, we're going to lose our oxygen, and we're going to make a new alkene. And it just so happens that this alkene is not a regular alkene. It's an alkene next to a carbonyl. It's an alpha beta unsaturated carbonyl. In this case, an alpha beta unsaturated ketone. Well, sure enough, once we get to here, we know from our other aldol chemistry, we can treat this with hydrogen and palladium on carbon, and we can get to here. And so the Wittig reaction, one of the early popular uses for the Wittig reaction was to actually alkylate ketones. You can start with a ketone, we'll halogenate it. So this would be the first step. Second step, we'd make our phosphonium salt. Phosphonium salts tend to be really stable. You make it, tends to precipitate out of a solution. You filter it, you have it. Well, we then can treat it with base often, and you can have the aldehyde present in the reaction. So this reaction would have both base and aldehyde in there together. We make the ylide, the ylide reacts, makes the alpha beta unsaturated ketone, and then step 4, we would reduce it with hydrogen and palladium. So here is using things like the Wittig reaction. This doesn't look at all like we're getting ready to make an alkylated ketone, but we completely are, and we do this nice simple chemistry, and it works actually fairly well.